Hi everyone, I am Kavita. Today in this lecture we are going to see some basics definitions in deterministic finite state automaton or automata theory. When a string is said to be accepted by a given finite automaton. Actually, a string is said to be accepted by a finite automaton if it takes the machine from initial state to final state. So, initial state to final state, the string can takes the automaton, that string can be accepted by the automaton, we say. Okay. So, the next, define transition graph. The transition diagram is defined as a graph with circles, arrows and arcs with labels. Okay. Actually, the circle with arrow mark called as starting state and a double circle called as a final state in the diagram. Okay. Each circle corresponds to each state and the directed edge indicated the transition from one state to another state. Okay. In the transition table is defined as a conventional tabular representation of a transition function in which row correspond to states and the column correspond to inputs. In this row the states are specified with the arrow mark, that state is called as start state, and a state specified with a star means it is a finite state in the transition table. Okay. The entries of the table indicate the transition of DFA. The entries of the table indicates the transition of DFA, which string can takes the which state to which state. Okay, that and all specified in the table. Okay. Define NFA. What is NFA? And NFA also contains 5 tuples like the DFA, Q, sigma, delta, Q naught and F. Q is set of finite states, M named as a machine, and sigma is a set of input symbols, delta the transition function. Here the delta transition function Q, set of state Q, reads the input symbol sigma and it moves to twice the set of states. Okay. Actually, in DFA, a single state only it moves. Here, the Q only present in DFA definition. Here in NFA definition, we have 2Q. Okay. Q naught is a start state and F set of final states. Okay. Set of final states. Define a string. What is a string? The sequence of symbols obtained from the alphabet of a language is called a string. Actually, it's set of symbols. Okay, set of symbols or sequence of symbols obtained alphabets of a language is called a string. What is the length of a string? The length of a string means the number of symbols in the string. The number of symbols, how many number of symbols, that we call it as length. Okay, 2 symbols in that means we call the length is 2. Okay, 0 1, suppose for example 0 1 is a string, here 0 and 1 is present, so the length is 2. Okay. Define a language. A language is defined as a set of strings obtained from sigma star. Sigma star means it's a clean star, where sigma is the set of alphabets of a particular language. Define transition function of DFA. The transition function delta Q reads the set of strings sigma and send it to the next state Q. Okay. Specifies the state into which the machine will move on the basis of current state and the symbol it reads. Symbolic representation is delta of Qi. Qi means a state, A is a string, Qi reads the string A, okay, takes the input A and moves to the next state Qj. Okay, Qi is a state and takes the input A and moves to the next state Qj. This is the symbolic representation which says that there is a transition from the state Qi to Qj when the machine reads the symbol A. Okay. So, now the definition, transition function for NFA. Okay. The transition function delta, defined as Q, takes a set of symbols as sigma and moves to 2Q, specifies the state into which the machine will move on the basis of current state and the symbol it reads. The symbolic representation is delta of Qi. Qi is the current state and it reads the symbol A and moves to 2Q states, Qj and Qk. Okay, multiple states it moves. Okay, because since it is a NFA, suppose it is a DFA, means single state only it moves. Okay, this is the difference between NFA and DFA, which says that there is a transition from state Qi to Qj Qk when the machine reads the symbol A. Okay. What do you mean by transition in a finite automaton? A transition is nothing but change of state after consuming an input symbol. After consuming an input symbol from current state to next state it moves. That is called as transition. How a DFA processes a string. At first, input pointer points to a first cell of the tape pointing to the string to be processed. Actually, the tape head moves to the first step of the tape, input tape, and reads the first symbol only first. Okay. After scanning the current input symbol, the machine may enter into any one of the states and the pointer moves one cell towards the right. After reading one symbol, it moves to the next symbol. When the end of the string is encountered, the string is accepted if and only if the automaton will be in one of the final state. Finally, it should be in one of the final state. Then we call the string is accepted. Start state to final state, the string moves the automaton, then we call the string is accepted by the automaton. Okay. So, the next, define trap state. Trap state is a non-final state of a finite state machine whose transition on every input symbol terminates on itself. Okay. It should not takes to final state. It's trap state is not a deterministic state, non-final state of a finite state machine. Okay. Now, what is the difference between DFA and NFA? DFA, NFA. DFA, there can be 0 or 1 transition from a state on an input symbol. There can be 0 or 1 or more transition from a state on a input symbol in NFA. DFA contains more number of transitions, but NFA contains less number of transitions. DFA is difficult to construct, but NFA is easy to construct since it moves to many states, right? So, DFA is less powerful, but NFA is more powerful than the DFA. Okay. So, what is the need of NFA? And NFA is a efficient mechanism to describe some complicated languages concisely and has the power to be in several states at once. So, NFA is needed in such cases. Design DFA accepts 1A or 1B. A or B. Okay. So, 1A or 1A first. Q0 is the start state and also an end state. Do you look at this diagram? Start state mentioned with an arrow mark and end state is with double circle. So, here Q naught definitely accepts the A. Okay, since Q1 is not a finite state, Q naught itself a finite state and a start state, so definitely it accepts A. Okay, so here design a DFA to accept any number of A's. Just a self loop with a start state and end state as a single state Q naught, then it takes many A's, many number of A's again and again and again and again. Okay, so this is the DFA to accept the symbol many number of A's. Okay, give an example of a finite automaton. Traffic light is also a finite automaton. It automatically changes its colors. Okay, and vending machine, any of the type of vending machine, cool drinks machine and Pepsi, Coke, that and all, and vending, many things nowadays vending machines can give, right? And the ATM machine, generally we are using this ATM machine. ATM machine is one of the type of automaton. Automatically it gives the money to us, right, on putting our card. Okay, so here define NFA with epsilon transition. And NFA with 0 or more epsilon transitions is called a epsilon NFA. Okay, when string is said to be accepted by NFA with epsilon transition. This is a question. So now the answer is, a string is said to be accepted by NFA with epsilon if at least one path exists that starts at the initial state and end in one of the final state. Start at the initial state and end at least one of the final state. Okay, the path formed contains state with transition from epsilon transition or non-epsilon transition. Okay, thank you. See you again in the next video.